Hi, I am Syed on Maths Online. Today's topic will be the method of variation of parameter. You can watch my previous video for the basics on the method of variation of parameters. We have even solved few problems in the previous video, so we'll continue with few more problems in this video. So let us take the first question. Solve d square y by dx square minus 2 times of dy by dx plus 2 times of y is equals to e power of x into tan of x using the method of variation of parameters. Let us first write in the form of the operator. This will be d square minus 2 times of d plus 2 times of y is equals to, it is e power of x into tan of x. So the auxiliary equation here will be m square minus 2m plus 2 is equals to 0. You can find out the roots of this equation. Just try to find out the roots of this quadratic equation. Coefficient of m square is 1. Coefficient of m is minus of 2. And the constant term is 2. So just try to observe. The first root will be 1 plus I. The second root will be 1 minus of I. Therefore the roots we have is 1 plus r minus I. Therefore the complementary function will be e power of, this is 1, so 1 times of x into, it is c1 cos of, coefficient of I is 1, so 1 times of x plus c2 sin of x. So if you try to rewrite this one, I can rewrite this as c1, you multiply e power of x inside, it is e power of x into cos of x plus here c2 as it is, multiply this e power of x inside, so e power of x into sin of x. So now if you write down the solution be y is equals to, so for the method of variation of parameter, the value of c1 can be replaced by a, this term e power of x cos x as it is, replace the value of c2 by b, e power of x into sin of x. So the solution is y is equals to a times of y1, b times of y2. So here your value of y1 is nothing but e power of x into cos of x, and your value of y2 is nothing but e power of x into sin of x. So let us try to differentiate this one. So y1 dash will be equals to, so you have to just use the product rule over here. So you have e power of x as it is, differentiation of cos will be minus sine, so it is minus sine of x. So keeping cos x as it is, differentiation of e power of x will be e power of x itself, cos x will remain as it is. Or suppose if I take e power of x common outside, then first write down the positive value cos of x, then the negative value sine of x. This is y1 dash. Similarly try to differentiate this one, so y2 dash will be, so once again the product rule, so keeping e power of x as it is, differentiation of sine of x will be cos of x, plus keeping sin x as it is, differentiation of e power of x will be e power of x, so e power of x into sine of x. So once again you can take e power of x common, so we will be left out with cos of x plus sine of x. Now if you go for Wronskian W, it is y1 y2 dash, y1 y2 dash minus y2 y1 dash, so y2 y1 dash. So just let us multiply this one, y1 y2 dash. You have e power of x into cos of x multiplied by this particular value, e power of x into cos of x plus sine of x minus y2 value is e power of x into sine of x times of, you have e power of x into, it is cos of x minus sine of x. This will be nothing but, now you can multiply e power of x, which will be nothing but e power of, because bases are the same, you can just add the powers. So x plus x will become 2x. Now you just multiply this cos x inside. So cos x into cos x will be cos square of x plus again sin x into cos x, sin x into cos of x. So here again e power of x into e power of x will be e power of 2x. So you multiply this sin x inside. Sin x into cos x, sin of x into cos of x, minus of again sin x into sin x will be sin square of x. You can just observe over here e power of 2x into sin x cos x, here minus e power of x into sin x cos x. The positive and negative will cancel out. So you will be left out over here in these two terms. E power of 2x I can take common. So you will be left out here with cos square of x. You have minus of minus plus sin square of x plus sin square of x. Cos square of x plus sin square of x will be 1. So you are left out with w is equals to e power of 2x. So you got the Wronskian value to be equals to e power of 2x. And also given the value of phi of x, the right hand side of the given differential equation is e power of x into tan of x. So now we'll try to find out the values of a and b. So a is nothing but minus integral of y to phi of x divided by w times of dx plus k1. So that is nothing but minus integral of, your value of y2 in this problem is e power of x into sine of x into phi of x is nothing but e power of x into tan of x whole divided by the Wronskian w is e power of 2x times of dx plus the constant k1. So we know that this e power of x into e power of x that you have is nothing but e power of 2x. So e power of 2x in the numerator and e power of 2x in the denominator, that will cancel out. That is nothing but minus integral of. So this sine of x as it is, tan x can be written as sine of x by cos of x into dx plus this constant k1. So it is minus integral of sin x into sin x can be written as sine square of x divided by this cos of x into dx plus the constant k1. So that is minus integral of sine square of x can be written as 1 minus cos square of x divided by this cos of x into dx plus this constant k1. So that is nothing but, you can divide this cos x with each of the terms. So 1 by cos of x minus integral of 1 by cos of x will be nothing but secant of x into dx. Again you multiply this negative sign inside. So minus of minus will become plus integral of, you have cos square of x by cos of x. So one cos will cancel out, you'll just be left out with cos x. Cos square of x by cos x will be cos x into dx plus this constant k1. So this will be nothing but minus of integral of secant of x will be nothing but log of secant of x plus tan of x, and integral of cos of x will be nothing but sine of x plus this constant k1. So we have got the first value a. Now we need to find out the value of b. So the value of b will be integral of y1 into phi of x divided by w times of dx plus the constant will be k2. So the value of y1 that we have is e power of x into cos of x into the value of phi of x is e power of x into tan of x divided by w value is e power of 2x into dx plus this constant k2. However, this e power of 2x will cancel out with e power of x in the numerator. So this can be further written as cos of x as it is. Tan x can be written as sine of x by cos of x into dx plus this constant k2. So you can cancel out this cos and cos. you just left out with integral of sine of x into dx plus the constant k2. So integral of sine of x is nothing but minus cos of x plus k2. So substitute the values of a and b in equation number 1. So the value of y will be nothing but a into. So the value of a that we have over here is minus log of secant of x plus tan of x plus sine of x plus k1. A into, it is e power of x into cos of x plus b. So b value over here is minus cos of x plus k2. b into, it is e power of x into sine of x. So y will be equals to, here let me write first this value of k1 cos and k2 sine. But in both these cases e power of x is common. So if I take e power of x common outside, so we are left out with k1 cos of x. Over here it is k2 sine of x. Now in the remaining terms also e power of x is common. So I will take e power of x common outside. So then this minus log has to be multiplied by cos. So we will be getting minus cos of x into, it is log of secant of x plus tan of x. Then this sin x is multiplied by this cos x. So plus, since I have already taken e power of x outside, you will be left out with sin of x into cos of x. And coming to this term, here also e power of x is taken common outside, we will be left out with sin x into cos x with a negative sign, minus sin of x into cos of x. So let us try to simplify this one. So this positive and negative value will cancel out. You will be left out with y is equals to e power of x times of, it is k1 cos of x plus k2 sine of x. Because here you have negative sign, so negative sign you can take outside. So minus into plus will become minus e power of x into. So you are left out with this cos of x into log. So cos of x into this log value. So log of secant of x plus tan of x. So that's the required solution. That's all I have for today. Thank you.